This is video number 5 in the video series for Unit 3, Part 1, Lecture PowerPoint Notes. This is the last video in the video series. We're going to take a look at something called periodic trends. And it can also be classified as something called periodicity, which means a repeating, rising, and falling pattern. So this graph on this slide shows that there is a periodicity in the atomic number, the atomic radius based on the atomic number of elements. And so we see that there's a rising and a falling, and that represents the periodicity. What are the major periodic trends that you should be familiar with? We're going to take a look at atomic radius, metallic character, ionization energy, and electron affinity. The atomic radius trend is that the size or the radius of atoms is going to increase as we go from the top to the bottom of the periodic table. And if you remember in one of the earlier videos, we mentioned that as we go across the periodic table from left to right, we end up getting more and more protons, right? If we have more and more protons and more electrons, the attraction between them gets stronger and stronger. So as we go across the periodic table from left to right, not including the transition metals, we're talking about the tall buildings, right? That those atoms are going to get smaller and smaller. And the reason being is because the electrons are more attracted to the protons because there's more protons and more electrons as we go across the periodic table. And the fact that they're in the same energy level, right? So the number of the periods as we go down the periodic table is related to the energy levels, which you'll learn in part 2 of the lecture notes. So taking a look at this graph, as the atomic number increases, right, we look at these points up here at the top. This is group 1, lithium, sodium, potassium, rubidium, cesium, and franconium, right? And so if we look at this graph, the atomic radius gets larger and larger as we go down the periodic table. If I look from lithium to fluorine, right? If I'm looking from lithium to fluorine, these are all in the same period. Lithium has a larger atomic radius than fluorine. Same thing as we look at sodium and chlorine. So these are just looking at the atoms that are in groups 1A through 7A. We're not looking at the transition metals, right? Here we're looking at transition metals. There's a variability in the size. They can go up and they can go down. It doesn't remain consistent. But when we're looking at those elements that are in the main group elements, we consistently see that as we go across from left to right, the atoms get smaller and smaller. So the trend is that atomic radius increases from top to bottom and from right to left on the periodic table. Metallic character has to do with the ability of atoms to lose electrons. So the easier an atom can lose an electron, the more metallic character that they have. And we end up having more and more energy levels where electrons reside. They're farther away from the nucleus. And the farther away those outer electrons are from the nucleus, the easier they are to be lost from the atom. So as we go down the periodic table, the atoms get larger, and so does our metallic character, the ease of losing electrons, right? And so the smaller the electron, the smaller the atoms are, the harder it is for them to lose electrons. So our metallic character increases from top to bottom, and also from right to left. It follows the atomic radius trend. The next 2 trends we're going to take a look at is ionization energy and electron affinity. They both have the same trend in that they increase from bottom to top and from left to right. It's opposite of the atomic radius and metallic character. And what can we say about them? So the ionization energy is the energy that is absorbed by an atom in its gaseous state that allows it to lose or to remove one electron. And so electrons are removed one at a time to form ions. And so the ionization energy, the energy required to form an ion by removing an electron, is going to get higher and higher the smaller the atom is, right? So atoms with low ionization energy are going to be at the bottom left of the periodic table. Electron affinity has the same trend, that if I have electrons that are closer to the nucleus because the atomic radius is smaller, those electrons are going to be more attracted to the nucleus because they're closer, and it's going to be harder for me to lose an electron. However, it will be easier for me to hold on to electrons or to steal electrons if they come in contact with another atom that is able to lose electrons easily. So electron affinity is the energy that is given off by adding an electron to an atom in its gaseous state. So those atoms that are smaller are able to take electrons easier from other atoms that are easy to lose electrons. So looking at helium, neon, argon, these are our noble gases. And so we notice that the ionization energy decreases as we go down the periodic table, right? We're going down the periodic table, but notice that they're high nonetheless. They're higher than all of the other atoms in the same period. So if I'm looking at lithium versus neon, lithium has a low ionization energy. Its energy is the energy to remove an electron from lithium is going to be lower than it would be from neon. Neon isn't really reactive, so it doesn't want to lose electrons or gain electrons, right? Electron affinity follows a similar pattern. So let's take a look at this. The atomic radius increases from top to bottom and from right to left. Metallic character also increases from top to bottom to right to left. So atoms with the largest atomic radius are going to be on the left bottom, and they're going to have the most metallic characteristic. And we know that to be true. We know that on the right side of the periodic table, we have nonmetals. So that makes sense that the atoms that have the least metallic character are going to be on the top right of the periodic table. Ionization energy, or the energy required to lose an electron, or the energy that is going to be given off when gaining an electron, is going to be high on the right, top right, also because of atomic radius. The smaller the atom, the more energy is going to take to lose an electron, and the more energy that is released when gaining an electron. Okay, so let's do a little bit of practice. Let's order the following atoms from largest to smallest and from most metallic to least metallic. Pause the video. Pause the video and see if you get the answers right, and come back when you're ready to check your answers. Are we ready? All right, let us identify the atoms that we're looking at. We're taking a look at sodium, phosphorus, chlorine, potassium, and sulfur. And we want to order the atoms from largest to smallest. Well, remember that our atomic size increases going down the periodic table, that it increases as we go down the periodic table, and it also increases going from right to left. So if we want to go from largest to smallest, we're going to start at at the lower part. We're going to start down here with potassium, move our way up and go across. So to put these in order, it would be potassium, sodium, followed by phosphorus, sulfur, and then chlorine. Let's take a look at the second question. We're ordering the atoms from the least to the most metallic. Well, we know that down at the bottom left is going to be the most metallic. And up here at the top right, we're going to be the least metallic, right? So we are looking at cesium, fluorine, zinc, rubidium, and zirconium. And so if we're going from most to least metallic, we are going to go once again from bottom to top. So where would we start? We would start with cesium, followed by rubidium, followed by zirconium, followed by zinc, and lastly, fluorine. Okay, don't forget that transition metals are still metals, right? And so we can still classify them based on their metallic character. This last slide here on your lecture notes are a set of links that you can use to help you learn more about the topics that were presented in this series of videos.